Hi students. So in the last video, I explained how to find the probability or interval of a normal distribution using the table with an example. Today we will look at more problems. So in this all the problems, I'm directly taking that values. Okay, I'm not going to that show that table again because you already learned, so which I explained in detail in the last video. Okay, I take the next problem. Problem number two. Problem number two says that if x is a normally distributed variable, normally distributed variable with mean 30, with mean 30 and standard deviation 4, find number 1 p of x greater than 40, p of x greater than 40. Number 2 p of x less than 21. Number 3 p of 30 less than x less than 35. Okay, now in this problem the mean and standard deviation is given, and it's given that the distribution is normal. Okay, that means mu equals 30, standard deviation sigma equals 4. Already explained in the general procedure, we always start with the substitution. The substitution is put z equals x minus mu by sigma, and in this case mu is 30, so write x as it is, x minus 30 by 4. Okay, now let's consider the first one. Now the first one is we have to find out p of x greater than 40. Now we have to convert this into standard normal variable z using this substitution. Using the substitution, we have to convert this into standard normal distribution. Okay, now for x equals 40, z equals 40 minus 30 by 4, that is 10 by 4, which equals 2.5. Therefore, this p of x greater than 40 is same as p of x greater than 40 is same as p of x greater than 40 is same as p of z greater than 2.5. And we know that whenever you got p of z greater than something, means it is from p of the 2.5 to infinity, 2.5 less than z less than infinity, which equals 2. So probability over a positive interval in z, it is a or phi of upper limit, which is a of infinity minus a of 2.5, and we know that a of infinity is 0.5. So this value is 0.5 minus a of 2.5. From the table, we get a of 2.5 as 0.4938. 0.4938. Simplify, this becomes 0.0062. Okay, second one, p of x less than 21. Okay. Now for x equals 21, we have to find out z. For x equals 21, z equals 21 minus 30 by 4, which is minus 9 by 4, which equals to minus 2.25, minus 2.25. So therefore this probability of x greater than 21 is same as probability of z less than minus 2.25, which means probability of minus infinity less than z less than minus 2.25. So it is a probability over a negative interval. Now we have to change it to probability over a positive interval. So this can be written as P of 2.25 less than z less than infinity. Now once it is converted into probability over a positive interval, so using the result you can write as a or phi of upper limit, that is phi of infinity, minus phi of lower limit, which is 2.25. Now what is phi of infinity? It is 0.5 minus, and this we are getting from the table, phi of 2.25, and the value is 0.4878. 0.4878. So this simplifies to 0.0122. This is the probability of x less than 21. Now let's consider the case number 3. Here in case number 3, we have to find out probability in the range, which is P of 30 less than x less than 35. Now here you have to find the two z values. One is for x equals 30, one is for x equals 35. Now for x equals 30, z equals 30 minus 40 by 4, which is minus 10 by 4, minus 1 you are getting. And similarly, for x equals 35, for x equals 35, z equals 35 minus 30. This is 30 minus 30, sorry, which is 0. Which is 0, not 1, it's 0. Okay, here the this mu is 30. Okay, for 35, z equals 35 minus 30 by 4, which is 5 by 4, which is 1.25. Therefore, this becomes P of 0 less than z less than 1.25. You can directly write it as a or phi of this, or you can write it as a of 1.25 minus a of 0, and a of 0 is 0. You can neglect this. So just it is a of 1.25, which equals to 0.3944. Okay, so this is the required probabilities. This is how we can find the probabilities easily, just by making use of the table and converting the variable x to z. Now let's move on to the next problem. Again, an application problem. Here the problem says that the annual salaries of employees, the annual salaries of employees in a large company. In a large company is distributed, normally distributed, is normally distributed with mean, distributed with mean of 5 lakhs rupees, 5 lakhs rupees, and a standard deviation of 2 lakhs. Now, if a person is selected, if a person is selected at random, selected at random, what is the probabilities? What is the probabilities that annual salary is number 1 less than 4 lakhs, less than 4 lakhs. Number 2, between 4.5 and 6.5 lakhs, between 4.5 and 6.5 lakhs. And number 3, more than 7 lakhs. Okay, this is an application problem where the normal variable is nothing but the annual salary of employees in a large company. Okay, so here it's given that mean salary mu equals 5 lakhs and standard deviation equals 2 lakhs. These are the values given. Mu is 5, that is the mean salary, and the standard deviation is 2 lakhs. Okay, that is 2. Now let's do this substitution. Put z equals x minus mu by sigma, that equals 2. X minus mu is 5, sigma is 2. Now, first one is nothing but probability that salary of a person, annual salary of a person or an employee is less than 4 lakhs, less than 4 lakhs, which equals to P of x less than 4. Now, for x equals 4, what is z? 4 minus 5 by 2, that is minus 1 by 2, that is minus 0.5. Therefore, this is same as P of z less than minus 0.5, which equals probability of minus infinity less than z less than minus 0.5, which equals probability of 0.5 less than z less than infinity, which is equal to a or phi of infinity minus a or phi of 0.5. And we know that a of infinity is 0.5 minus a of 0.5 is, from the table we are getting it, and it is 0.1915. 0.1915. Subtract, you are getting 0.3085. That means probability that an employee's salary is less than 4 lakhs is 0.3085. Now the second case. What is the second case? In the second case, we have to find the probability that a person's salary is between 4.5 and 6.5 lakhs. Okay, that is P of 4.5 less than x less than 6.5. There is a person's salary is between these two values. Okay, now this you have to convert into P of Z. For that, we have to find the corresponding values of x. Z for x equals 4.5. Z equals 4.5 minus 5 by 2. That is minus 0.5 by 2 minus 0.5 by 2, which equals to minus 0.25. Next, for x equals 6.5, what is z? Z is 6.5 minus 5 by 2, 1.5 by 2, which equals to 0.75. Okay. Now, therefore, this becomes P of minus 0.25 less than Z less than 0.75. Now, if it is negative to positive, so using the result, you can write it as phi or A of upper limit, that is A of 0.75 plus, not minus here because this is negative, plus A of absolute value of this, that is 0.25. So which becomes, and what is A of 0.75? And A of 0.75 is 0.2734 plus A of 0.25 is 0.0987 from the table. So that simplifies to 0.3721. Okay. The next case is probability of that salary is more than 7 lakhs. That means P of x greater than 7. So for x equals 7, what is z? 7 minus 5 by 2, which equals to 2 by 2, which equals 1. Therefore, this becomes P of z greater than 1, which is P of 1 less than z less than infinity, which equals to A or phi of upper limit infinity minus A of 1, and A of infinity is 0.5 and A of 1 or A of 1.00 is 0.3413. This simplifies to 0.1587. Okay. Now, so next we take slightly different kind of problem. Slightly different, where one additional thing is included. Okay. Now first I'll read out the problem. I'll write it on the, this whiteboard. The problem says that the marks of 1,000 students, marks of 1,000 students in an examination is normally distributed, or it's follow normal distribution. ND means normal distribution with mean 70 and variance 25. Find number of students. Find number of students whose marks will be number 1, case number 1, less than 65. Number 2, Number 2. More than 75. More than 75. Number 3. Between 65 and 75. It's a model question paper problem here. So in what way this is different from the previous problem? So here first we find property that a student marks is this less than 65, more than 75, and between 65 and 75. First we find that probability. Then multiplying by the 1000, the number of students, we get approximate number of students who have got so much marks. That is the additional part. Okay, that's clearly given that it's a normally distribution. The variable, which is the marks, is a normal variable. Okay, so here mean is given as 70. Variance, you have to be careful. It is not standard deviation. Variance is given as 25. But we require the standard deviation. It is nothing but sigma, positive square root of this, which is root 25, which equals 5. Don't take 25 because it is a variance. So we require standard deviation, which is a square root of it, which is 5. Now, that is the first step is same, and in fact it fetch you 1 mark easily. The substitution, that is put z equals x minus mu by sigma, and x is the variable, normal variable, mu is 70 here, and what is that sigma? 5, not 25, it's 5. Okay, now first I'll find probability that a student has scored less than 75, which equals less than 65, no 75, less than 65, which equals P of x less than 65. Now, so here x is 65. We have to find out z. For x equals 65, what is z? 65 minus 70 by 5, that is minus 5 by 5 minus 1. Therefore, this becomes P of z less than minus 1, which is P of minus infinity less than z less than minus 1. So, which is a probability over a negative interval. Converting into positive interval, you are getting P of 1 less than z less than infinity, and which is equal to a or phi of upper limit, which is infinity, minus a of 1. A of infinity is 0.5 minus, and a of 1 is 0.3413. 0.3413, and it becomes 0.1587. But we want number of students who have scored less than 65 marks. So, number of students who have scored less than 65 marks equals total number of students 1000 in this case, multiply by this probability value. This probability that a student scored less than 65, that is 0.1587. If you multiply, you are going to get 158.7 but you can't leave the answer in this form. You have to round up to the nearest integer because its number of students is a whole number. So this becomes 159. That means, so there are 159 students out of 1000 students. We have scored the less than 65. Now let us consider the number of students who are scored greater than greater than 75. Okay. Second one, number of students who have scored greater than 75. I'll find directly here. It is 1000 multiplied by P of x greater than 75. So this is the total number of students. This is the probability that a student is scoring greater than 75. Or like the previous case, you can find this separately, then multiply by 1000. Now, for x equals 75, z equals 75 minus 70 by 5, which you are getting 1. Therefore, this becomes 1000 into P of z greater than 1, which equals to 1000 into P of 1 less than z less than infinity. See, this is exactly the same as the previous case. So multiply by 1000, you are going to get the same answer. So I won't repeat because you're getting the same answer. So I can write directly. So approximately 159 students scored greater than 75. Now consider the last case. The number of students who have scored between 65 and 75, which is nothing but 1000 multiplied by P of 65 less than x less than 75. So which I write directly. The reason is I already found out for x equals 75 what is z. Z is minus 1. And for x equals 75 in the second case we have got z is plus 1. So which is 1000 multiplied by, so it is upper phi of negative to positive, phi of upper limit plus phi of or a of absolute value of the lower limit, which is minus 1 absolute value plus 1. So this becomes 1000 into 2 times phi of 1, and phi of 1 is nothing but 2000 into what is phi of 1, same as the previous one, which is 0.15, 0.3413, 0.3413. If you multiply, you are getting it as 628.6, 682.6, which is not rounding off, we are getting 683 students. That means there are 683 students out of 1000 students. We have got score between this. If you want, you can verify. If you add these three, so you have to get a value which is just one greater than, because you have approximate or equal to 100. In fact, 9312 plus 21 2 carry 2 8 is 10, 10 plus 10 20 2 carry. Okay, you are getting sum as 1001. Where you got this one extra? Because here are rounded off. You should think that is getting one extra. Okay, fine. So this problem is different in the previous problem. In what way? This is the addition factor. The addition factor is multiplying by 10,000 to get the number of students. In the same way, we take one more different kind of problem. That is the last problem here, where we are finding the mean and standard deviation by knowing the probability value. So far, in all the previous remaining problems, we have found out the probability values by knowing the mean and standard deviation. It's the other way. It's the other way. Okay. The problem goes like this. Find mean, that is mu, and standard deviation sigma of a normal distribution of a ND, means normal distribution in which 7% of items are under 35 and 89% are under 63. Okay. Now, the data given is this. Normal distribution, X is the normal variable, 7% of the item, that is probability of X less than 35 equals 7%, that is 0.07. Okay, from this you have to get one equation in X and mu and sigma. We'll find out that. What is the substitution? Put Z equals X minus mu by sigma. Okay. So for X equals 35, what is Z then? 35 minus mu by sigma. Therefore, this becomes P of. So 35 minus mu by sigma less than, Z less than, in place of X you write Z less than 35 minus mu by sigma, and the value is nothing but 0.07. So the given condition in terms of the standard normal variable becomes probability of Z less than this equal to 0.07. That is probability of minus infinity less than Z less than 35 minus mu by sigma equals 0.07. So far we use the proper result to find the probability of the or into the standard normal variable Z. There we, in the earlier problems, we come to know what about these constant, whether positive or negative. But here we are not knowing whether this is positive or negative. This is negative. Okay. Now how to find out that? Look at the right hand side. The right hand side is less than 0.5. If this is less than 0.5, it is 0.07 less than 0.5, then this interval is either a part of negative interval or a part of positive interval. If this is greater than 0.5, the right hand side is greater than 0.5, then this is from negative to positive. Then only you are getting greater than 0.5. Okay. Now, since this is less than 0.5, so this has to be negative or positive interval, whereas this is already negative. Therefore, this must be negative. Okay. If this is positive, then this must be positive because their RHS is less than 0.5. So, since this is negative, we can write it as probability of negative of this. We have to make the absolute value of this, which is mu minus 35 by sigma less than Z less than infinity equals 0.07. Now, this is by the result A of upper limit minus A of lower limit by, this equals to 0.07. Now, A of this is 0.5 minus A of mu minus 35 by sigma. This equals 0.07. Now, bringing this to the right hand side, minus A of mu minus 35 by sigma equals 0.07 minus 0.5, which is minus 0.43. Minus minus cancels. Okay. Now, we have to look for the table and we have to find out A of Z, which is nearly equal to 0.43. From the table, it is given, you can find out that A of 1.48 is equal to 0.4306, which is near equal to 0.43. Therefore, we can replace this by a 1.48. That means you are getting A of mu minus 35 by sigma equals a 1.48. That means these Z values must be same. There is mu minus 35 by sigma equals 1.48. Cross multiply, bring it to this side. From that, you're getting the first equation, namely mu minus 1.48 sigma equals, bringing 35 to the other side, plus 35. Call this equation as 1. Mu minus 1.48 sigma equals 35. Now, so using the other condition, we have to find one more such equation. What is the other condition given? It's given that 89% are under 63. That is, P of X less than 63 equals 89%. That is nothing but 0.89. Okay. Now for X equals 63, that becomes 63 minus mu by sigma. Therefore, this is given as P of Z less than 63 minus mu by sigma, which equals to 0.89. That is probability of minus infinity less than Z less than 63 minus mu by sigma equals 0.89. Now, look at the right hand side value. It is greater than 0.5. Therefore, the interval must be negative to positive. So, we already got negative sign here. Therefore, this must be positive. Suppose if this is less than 0.5, then this interval has to be positive or negative. Since this is negative, you have to take this as negative. Fine. So, here greater than 0.5, therefore, it is from negative to positive. Then only you are getting greater than 0.5. Okay. Therefore, so using the result, you can write it as A or phi of 63 minus mu by sigma, that positive value, plus phi of infinity equals 0.89. This is 0.5. Substituting and similarly here. So you're getting phi of 63 minus mu by sigma equals 0.89 minus 0.5, 0.39. Now from the table, we are getting that phi or A of 1.23 equals to 0.3907, which is nearly equal to 0.39. Therefore, this I have to replace by 1.23. Therefore, these two are equal. Therefore, 63 minus mu by sigma equals 0.39. Cross multiply. 63 minus mu equals 0.39 sigma. That is minus mu minus 0.39 sigma equals minus 63 multiplying by minus 1. We get mu plus 0.39 sigma equals 63. This is the second equation. Now these are equation in mu and sigma. Equation number 1, this one, mu minus 1.48 sigma equals 35, and equation 2 is this. Solve this using the calculator. Solving, you're getting x and y. X is nothing but mu. You're getting mu equals 50.2915, and second y you're getting in the calculator, that y is nothing but sigma here, which is 10.3321. This is how we have to solve this problem. Okay, that completes all kinds of problems. So with this you can easily work out the problems on normal distribution, any kind of problems. Okay, so very important topic, this normal distribution, because you are using it in the next module also. There is module 6, okay, in the sampling theory. Okay, I'll start with that module 5 in the next video. Okay, fine, thank you.